Welcome back. So today we're going to be going over the next lesson in this course, which is going to be 1.8 Statements of Logic. And if you haven't watched my previous lesson, I recommend you do so. But I don't want to waste any more of your time, so let's get right into it. So this lesson has to do with just conditional statements and in general how logic works. Um, Now, if you want to, you could technically skip this lesson, but I still think it's important to know the logic, right? Um, and when I say logic, I mean like converse, right? Which we kind of went over, inverse, contrapositive, all of those terms. So first off, right, let's just talk about what a conditional statement is. And I did briefly go over this in a previous lesson, but essentially a conditional statement is a sentence that's in the if-then form, right? And this will look familiar to you if you've been memorizing theorems, right? So, right, the if part and then there's the then part. Um, Now, many like normal sentences, right, can be written in conditional form, and by normal I mean like declarative sentences that declare something. So, for example, you see the sentence right here, right, that two straight angles are congruent. This can be transformed into the if then, right, the conditional form by saying if two angles are straight angles, then they are congruent. Right? So again, this part here, right, that if part is what you can kind of call like the condition, right? That's where the term conditional comes from. So if that condition is fulfilled, right, if two angles are straight angles, then you can uh, have this result, right, with this kind of result that they're congruent. So as long as this first condition is met, you can determine that, right? Now, an important thing to note is negation, which is essentially if you have a statement P, then the negation of that, right, is just going to be not P, right? That's pretty simple, right? Um, so anytime you have a statement, a negation is just nullifying it, like, or is doing the opposite. So again, P would turn into not P. And yeah, the notation sometimes you'll see this squiggly line here, right? That just means not P. Okay, now this is the most important part of this lesson. This is my PhD here. And the reason is because you have to know certain relationships like inverse, converse, and contrapositive, which are actually pretty important to know. So let's assume you have a basic statement, right? PQ. And I know it's a conditional statement is like an if-then form, right? Just imagine that the P is the if and then the Q is the then, right? So if you have a that basic P to Q, right? If P then Q, then the converse, and I've mentioned actually converse a couple of times before, the converse is just flipped, right? So instead of saying if P happens, then Q happens, you would say if Q happens, then P happens, right? So the simple relationship between the basic conditional statement and the converse is that you just flip the two parts, right? So again, P to Q becomes Q to P. Now, what is the inverse? Well, again, using that basic statement, this goes to negation, which is kind of like the not part, right? So if you have a conditional statement, a base conditional statement for P to Q, then the inverse of that statement is actually going to be not P to not Q, right? So again, if you have an inverse, you're just nodding both sides. So it goes from P to Q to not P to not Q, right? So once again, that's pretty simple, right? Now, if you want an example of how that would sound like, well, let's use this basic conditional form here, right? If two angles are straight angles, then they are congruent. If you want to do the converse of that, then it would be if two angles are congruent, then they're straight angles, right? That's the converse. You're just flipping those two statements. Or you're just switching them, right? Now for inverse, right, you would say if two angles are not if two angles are not straight angles, then they are not congruent, right? So that would be the inverse. You're just negating each part. Now, are those statements that I gave in the examples true? Not necessarily. right? Not all converse statements and not all inverse statements are true. So now, finally, let's discuss contrapositive, right? An important thing you should know about a contrapositive relationship is that if you ever have a contrapositive of a conditional statement, it's also going to be true. It's always going to be true. So the contrapositive of a statement is always true, whereas the converse and inverse are only sometimes true. So what is a contrapositive? Well, you can think of it as a combination of both converse and inverse. So not only do you switch the order, right? So not only does it go from Q to P, but you also negate it. So it goes not Q to not P, which is what you see here. So again, I think if you understand those basic relationships, you're in a really good spot. So contrapositive statements are always true. Converse and inverse are only sometimes true. Okay, next I want to talk about this kind of flow of logic. And what I mean by that is, let's say we have a conditional statement of P to Q, right? So if P then Q, right? And we're also given another conditional statement, if Q then R, right? What you can actually do is, because P goes to Q and Q goes to R, right? You can actually say P goes to R, right? Because Q becomes that link, right? Think of it almost as like, I know in a previous lesson, or in a future lesson, we're going to go over transitive and substitution properties. But um, again, if P goes to Q and Q goes to R, you can logically, right, say that P goes to R. Now, why is that important? Well, here I'll give you an example, right? So let's you have an if you have if then statements here, right? So you essentially have, if you study hard, then you'll earn a good grade, right? So that acts as our PDQ. Then the second step, right? The second thing given is that if you earn a good grade, then your family will be happy, right? So that's functions as a Q to R. So overall, what's the conclusion that you can make? Well, if you study hard, right, you earn a good grade, and if you earn a good grade, then your family will be happy. In other words, like ultimately, you can say that if you study hard, your family will be happy, right? So once again, it's a pretty simple flow of logic, right? If one goes to another and that other thing goes to another thing, you can connect those two together. So now here, right, I did mention to you earlier that sometimes the converse is true, right? Sometimes it's not. In the specific scenario where the converse of a statement is true, you call that a biconditional statement, right? So a biconditional statement is one where the base form and the converse of the statement are both true. An example of that, well, let's look. Let's say we have a base conditional statement. If two angles are congruent, then they have the same measure, right? So that's the basic. Now the converse, right? Again, remember converse, you just switch the order, right? So you kind of read it backwards. So now you're saying if two angles have the same measure, then they are congruent. Well, that's also a true statement, right? Because if two angles have the same measure, well, then that means they're equal to each other, which means they're congruent. So that's one example or one of when the base conditional statement and the converse are true, making it biconditional. Okay, and lastly, I have an example problem here that I want to discuss, right? So let's say you're given four of these conditional statements, right? So here, you're first given not C goes to not F, then you're given G goes to B, then P to F, and then C to not B. So what is the final ultimate conclusion you can make just by looking at those four given conditional statements? Okay, I'm hoping that you have at least tried this yourself. But when I look at this first, right, the first thing I did was switch the latter two given conditional statements to contrapositive. So I changed P to F and made it into a contrapositive statement, right? So instead of P to F, right, remember it would be um, not F to not P, right? Because you're not only doing the converse, but you're also negating. So this would become not F to not P. Same thing with this, right? Remember, first you switch the order of those two, right? So this becomes not B to C, and then you negate it, so this becomes B to not C, right? So that's how you find the contrapositive. So once I did the contrapositive of those two statements, right? Uh, that's given here. What I realized is, well, hey, we know G goes to B, right? G goes to B, and we also know that B goes to not C. So you can connect those two, right, with that chain of logic, then you will get that G actually goes to not C, right? Because G goes to B, but B goes to not C. Well, ultimately G goes to not C, right? So after determining that, well, I used the last statement that they gave us here, right? This first one here. We figured out that G goes to not C, and of course, we're given that not C goes to not F. So finally, we can make that link. We can chain those two together, and we get that G goes to uh, not P, right? So again, right, this is an important thing to know because if you're dealing with a lot of different conditions and relationships, then it's important that you know how to work around them, right? So that's actually that problem because sometimes you're gonna have like complex proofs with a lot of stuff going on, and you really do have to know how to deal with like multiple conditional statements. Um, but yeah, that was this entire lesson. I hope you at least understood somewhat. As long as you know the relationships, again, that should be fine, right? So if you have any questions, leave it down in the comments, and I'll see you next time.